Okay, so the purpose of today's lesson is we're going to talk about 5 different theorems that we can use to prove angles congruent. Everything we've done up to this point has been sort of support knowledge for geometry. Now we're kind of getting into the meat of what geometry is. All right, so today we're just going to introduce 5 theorems, and some of them are kind of tricky to get your head around, but I hope I can explain it so that you understand it. Looking at the first one, theorem 2.1 says vertical angles are congruent. So first of all, a vertical angle, what that means is when we make this little X shape, vertical angles are the angles that are opposite of each other. So this angle is vertical with this angle. This angle is vertical with this angle. So what they're saying here, that in this particular example, that angle 1 is congruent to angle 2. And they're saying that angle 3 is congruent to angle 4. Notice when you make that X shape, all right, the angles opposite each other. 1 and 2 are opposite each other. 3 and 4 are opposite each other. Those angles are called vertical angles, all right? And there are proofs for this that we can find online, but we're not going to go into that in this course, all right? Just know that this is an important one to remember too. This comes up a lot in geometry. So vertical angles are congruent. That's one to really put to memory and remember. All right, theorem 2, it says if 2 angles are supplements of the same angle, then the 2 angles are congruent. So before we can really get our head around this, first of all, we need to figure out what supplement means. And all supplement or supplementary means is that it adds up to 180 degrees. All right, that's what a supplementary angle is. Okay, it adds up to 180 degrees. So think about this. If 2 angles are the supplements of the same angle, so what they're saying, if we look here at this particular angle 1, we notice that angle 3 is supplementary to angle 1 because it forms a straight line. All right, so angle 3 is a supplement of 1. But also notice here on this line, angle 4 is also a supplement of angle 1. And what they're saying is, if these 2 angles, 3 and 4, are both supplementary to 1, then 3 and 4 have to be equal to each other. All right? So that's what they're saying. If 2 angles are supplements of the same angle, then they have to be equal to each other. And that makes sense, because if 3 is supplementary to 1, and 4 is supplementary to 1, 1 doesn't change. So 3 and 4 have to be equal in order for them to be supplementary. All right. Now that doesn't mean that these are not the only supplements. Notice when we come up here to 4, we slide it. Let's rotate around here. 4, we have 1 is supplementary to 4, and 2 is also supplementary to 4. So 1 and 2 are also congruent. Notice also I picked this particular shape because it sort of reinforces what we learned up here, that vertical angles are congruent. Notice 1 and 2 are vertical angles, but they're also supplements of angle 4. All right, so you can find the rest of the supplements. If you slide down here, you can see that angle 2 is supplementary to 4 and 3, so 3 and 4 are congruent again, and you can keep on going around the wheel. So that's what that one means. Theorem 2-3, if 2 angles are complements of the same angle, then the angles are congruent. So this is sort of like a very similar theorem to what we just learned up here in 2.2. All right, complement, we need to know the definition of that. Complements or complementary means it adds up to 90 degrees. And these are very important definitions to remember. Supplement adds to 180, complement adds to 90. All right, so if we have 2 angles or complements of the same angle, then those 2 angles are congruent. So now this little confusing shape, notice we have a right angle drawn here, all right, and that's where this box comes from. And then we have a right angle drawn here, and that's where this box comes from. So notice in this particular, if we look at this angle right here, 1 and 2 together, 1 and 2 are complementary. They both add up to 90 degrees. But notice, if we look at this angle, this right angle, the one that's sort of straight up on your paper, 2 and 3, 2 and 3 are also complements of each other. They both add up to 90. So what it's saying, what this theorem is saying, is just like up here, that since 1 is a complement of 2 and 3 is a complement of 2, then angle 1 must be congruent to angle 3. All right? So it's the same sort of thing. I know those two sort of take a little bit to get your head around, but take some time and really think about that. Rewatch the video if you need to get your head around those. All right? Now we come to an easier theorem. This one's pretty straightforward. All right angles are congruent. Just remember that a right angle is equal to 90 degrees. So all 90-degree angles are equal. So that's sort of a straightforward thing. But you might use this later on when we're doing proofs. So it's kind of an important thing to remember. And then finally, theorem 2-5, if two angles are congruent and supplementary, then each is a right angle. All right, so remember we said supplementary adds up to 180. So if you have two congruent angles adding up to 180, that means that both of the angles must be equal to each other. So they obviously must be 90, right? If they're going to be congruent and equal to each other, then it has to be 180 divided by 2, which is 90, which is the definition of a right angle. Okay, so really pay attention to these proofs. These are very cornerstone kind of proofs in geometry, especially this top one and the bottom two. Put these to memory, and if you have any questions, bring them to class.